everybody. Today we're looking at the sections 2.1 and 2.2 homework. So we got 2.1 on the front, 2.2 on the back. Again, work with the rectangular coordinate system, graphing utilities, and section 2.2 is on circles. So it's first problem 11, find the distance and find the midpoint. So I'm given these 2 points here. So again, the distance is going to be the difference in the x's. So I'm kind of treating the distance formula as Pythagorean theorem. I'm going to do the difference in these x's. So minus 2 minus a negative 4 is plus 2 squared plus 7 minus 11 is minus 4 squared. Again, it doesn't matter the order you do them in because you're going to square it. So the difference in the x value squared plus the difference in the y value squared, and that's equal to the distance squared. That's 16 plus 4 is 20. And then the distance itself is going to be the square root of that. And then let's simplify this radical. So this would be 4 times 5, which is 2 root 5. For the midpoint, I'm going to average the x's and average the y's. So I'm going to add them up and divide by 2. Add up the y's and divide by 2. I'm going to average them. Add them up and divide by 2. Minus 2 minus 4 is minus 6 divided by 2 is minus 3. And then 7 plus 11 is 18 divided by 2 is 9. For problem 19, I need to determine if these 3 points form a right triangle. So any 3 points that aren't collinear define a triangle, but in order to form a right triangle, one of 2 things can happen. You can check all the slopes and see if 2 of those lines are perpendicular by seeing if the slopes are opposite reciprocals of each other. And another way to do it, and this is why it's in this section, is I can find the distance of the 3 sides, and then I can see if a squared plus b squared equals c squared, because that is only true for a right triangle. A squared plus b squared is greater than c squared for acute, and a squared plus b squared is less than c squared for obtuse. But the only triangle where a squared plus b squared equals c squared is the right triangle. So let's find the distance of the 3 sides. So I'm going to do these 2 points first. I'm going to do minus 1 minus 3 is minus 2 squared. 3 minus 1 is 2 squared. So 4 plus 4 is 8. And so then the distance itself is equal to the square root of that. And that is 4 times 2, which simplifies to 2 root 2. The second distance, let's do these 2. So let's do actually these 2 here. So this and this. So this is 1 minus 0 is 1. 3 minus a negative 2 is 3 plus 2, which is 5. So the difference in the x squared plus the difference in the y squared, that's equal to distance squared. That's equal to 26. So the distance itself is equal to the square root of that. And that's 13 times 2, 2 prime numbers, so that one's done. So the third distance between these 2 points here. So 3 minus 0 is 3. That's the difference in the x's. The difference in the y is 1 minus a negative 2, which is 1 plus 2, which is 3. So 3 squared plus 3 squared is 9 plus 9, which is 18. And so square root of 18 is 9 times 2. And you can take the square root of 9, which is 3, and that root 2 stays on the inside. Okay, so this is the biggest one. And you can kind of check it out, but the c is always going to equal the biggest side. So this is bigger than this. I can tell right here. Root 8, root 26, root 18. So this obviously has to be the biggest one. So this is going to be c. And it doesn't matter which one you call a or b. So this squared plus this squared, I'm checking to see if that equals this squared. So here's my little setup, and I'm not sure if it's equal. So this is, again, some hard work here. So this is going to be 4 times 2, which is 8. And then root 18 squared is just 18. And then root 26 is just 26. So this is 8 plus 18, which is 26. So that's a proof that these 3 points form a right triangle. Here's 29. Put both these together here. Okay, so 29, I want to know, identify the set of values of x for which y will be a real number. So in order to be a real number, we cannot put a negative under a square root. Otherwise, the I will pop out. And I is the imaginary number. So again, getting into restrictions on the variable. In terms of a square root, as long as what's under the square root is equal to 0, that's okay, because the square root of 0 is 0. Or as long as what's under the square root is positive, that's okay too. You just can't have under the square root to be negative. So if I take everything underneath and say I need this to be greater than or equal to 0, this will solve for the good set. I know in those previous sections we were looking for restrictions on the variable when we had x in a denominator. We're saying like, okay, x cannot equal this number or this number, any number that makes the denominator equal to 0. So we're solving for specifically the bad values. Now what we're doing is we're solving for the good set. So we're taking everything inside and saying greater or equal to 0. Subtract the 1.5 and then divide both sides by the -1. Don't forget to flip the symbol. So this is the inequality notation for that set of values that'll make y a real number. So this is going to be the domain of it. So 51, I'm looking for x and y intercepts. So a y-intercept is when x equals 0. An x-intercept is when y equals 0. That's the big thing to remember. The y-intercept is when x equals 0. The x-intercept is when y equals 0. So if I'm looking at this equation here and I just kind of hold my finger over this because x is 0, so this part's gone, and I'm just left with the equation 4y equals 12, divide by 4, and I get y value of 3. There's my y-intercept. An x-intercept is when y equals 0. So hold your finger over this or ignore this part because 4 times 0 is 0. And I have the equation negative 2x equals 12. So divide both sides by the -2, and I get negative 6 as the x value of the x-intercept. Okay, so 53, again, I want x and y intercepts. So y-intercept is when x is 0. So 0 squared is just 0. So then y equals 9. That's my y-intercept. An x-intercept is when y equals 0. So if this is 0, I get this equation here. I get x squared equals 9. Square root both sides. I get x equals plus or minus 3. So I have two values for x-intercepts in this case. Let's do the same thing for 57. So let's see what happens here. So an x-intercept is when y is 0. So if I put this is equal to 0, x equals -1. There's my x-intercept. A y-intercept is when x is 0. So if I put this equal to 0 like I did over here, I have an equation to solve. Let's add 1. So 1 equals y squared. Square root both sides. I get plus or minus 1 for that y value. So this case has two y-intercepts. So this one had two x-intercepts, and this one had two y-intercepts. Again, this is going to be like a normal parabola, like an upward, this one's going to be a downward facing parabola. And this one is going to be a sideways parabola. And we'll see more when we get into that. Actually, we can check it right now in Desmos if you want to see it. We can check these here. Let's go to Desmos. So that first equation is x squared plus y equals 9. X squared plus y equals 9. Oh, x squared plus y equals 9. And then I'm seeing this here. I'm getting, here are my x-intercepts, and there is my y-intercept. Let's make sure that works there. Bam and bam. X equals y squared minus 1. Y squared minus 1. I have one x-intercept and I have two y-intercepts. Zoom in a little bit here. Put this point here. This one here. Two y-intercepts and one x-intercept. So it's all matching up. Okay, 71. So I'm given the endpoints of a diameter, and I want to know the center and radius of the circle. Well, what I can do is, since I have the endpoints of the diameter, I can find the distance of that diameter using distance formula, and then just half that to get the radius. So I can do that. And then the center, I can use the midpoint formula to find the point that's right in the middle of that diameter, because that's where the center will be. Okay, so I have my 2 points at the end of the diameters, and here's my distance formula. Again, I'm going to use that idea of Pythagorean theorem. I'm going to take the differences in the x's squared plus the differences in the y squared, and that's equal to r squared, or distance squared, which in this case is going to be the diameter. So minus 2 minus 4, is minus 6. I'm going to square that. That's the difference in the x's. 1 minus 3 is minus 2. That's my difference in the y's squared. 36 plus 4 is 40. That's what the diameter squared is, or distance squared is. So the distance is root 40. And then let's see if we can simplify this radical. That's 4 times 10. And the square root of 4 is 2. I can take that out, but that 10 stays inside. So if the distance between these points, or the diameter, is 2 root 10, if I half that, it's just 1 root 10. 2 times root 10 divided by 2. Again, I can't get in the radical, but I can do 2 divided by 2 is 1. The center, I need to average the x values. I need to average the y values. So the average of these x values is negative 2 plus 4 over 2. So that's 2 divided by 2 is 1. And then 1 plus 3 over 2. Again, how do you average something? You add them up and divide by 2. 4 divided by 2 is 2. So 91, we're going to do some graphing here. Again, let's do this on our calculator here, just kind of practice our windows and things like that. So in problem 91, I'm going to graph kind of a big one here, but let's see if we can just put it in here. So it's 1400 x squared minus 1200 x. And I'm going to graph that. They told me the viewing window to do it on. So I'm graphing this on negative 5 to 5 by 1s. So those first numbers, that bracket, negative 5, comma 5, comma 1, that's the x-min, x-max, x scale. And then it says by negative 1,000, 2,500. So that's the y-min, y-max, y scale. So this is negative 1,000, 2,000, and then 500. And then if I graph that, I can see this parabola here. So again, all this problem is doing is just getting used to using our grapher, our calculator, and just moving things around. Okay, so 94, let's practice putting in square roots and absolute values on our calculator. So for 94, I'm going to graph square root. So I'm going to hit second, see the squared symbol right there. So second x squared is square root. And then put in that x plus 4. I'm going to start again, do a zoom. I'm going to hit 6, which is the standard window. And I get this square root arc right here. There's square root of x plus 4. So again, square root's under second right there. If I want to graph an absolute value, I'm going to hit math, go to the right num, hit enter on absolute value, and then I'm going to do x minus 2. And then this should be my nice V graph. So again, just practicing. There's a little shift there, which we'll get into in a little bit. So again, just practicing the different graphing techniques on the calculator. Okay, so that's the 2-1. Let's go down to 2-2. So we're going to do some work with circles. Okay, so for this one here, for problem number 9, okay, so I have this general form of x minus h squared plus y minus k squared is r squared. So the center is the opposite of this and opposite of this, so it's 4, negative 2. And then if this is r squared, the square root of that is the radius. So that's 9. Let's jump down to 19. Let's do the opposite of that. I'm told the center is negative 4, 1, and a radius of 3. So that means I'm going to write x plus 4 squared plus y minus 1 squared. Again, change the signs of those two, and that's equal to r squared. So if I graph negative 4, 1, that's my center. And then if I go 3 up, 3 down, 3 left, 3 right, I create the circle. For 25, endpoints of a diameter. So I'm given these two are my endpoints of a diameter. So what I'm going to do is I'm going to find the difference in my x's. So minus 2 minus 6 is minus 8 squared. Plus, find the difference in the y values. 4 minus a negative 2, 4 plus 2 is 6 squared. So again, it doesn't matter the order you do them in, because you're going to square it. So you find the difference in the x squared plus the difference in the y squareds, and that's equal to distance squared. So 64 plus 36 is 100. That's what d squared equals to. So the distance is 10. And the distance that I just solved for is the distance of the diameter. So if I half that, the radius is 5. For the center, I'm going to use the midpoint formula for these 2 points. Midpoint formula is all about averaging these x values and averaging the y values. So in order to average, I add these up. Negative 2 plus 6 is 4, divided by 2. 4 divided by 2 is 2. This is 4 plus a negative 2. So add them up, divide by 2. This is 2 divided by 2 is 1. So my center is 2, 1. My radius is 5. So that's going to be x minus 2 squared plus y minus 1 squared equals r squared, which is 25. For 41, so I'm given this big equation here, and I want to put this in that standard form. So I'm going to put like the bucket so I can figure out the center and the radius. Okay. So what I'm going to do is I'm going to kind of move stuff around. I move the x squared and the 6x together, and then I leave a little spot here. And then I have the y squared. I'm going to put the minus 2y next to that, and I'm going to save a little space there. And then I'm going to bring the 6 to the other side. So minus 6 plus, and I'm going to leave a little space here and here to figure out what numbers I'm going to add. So for this one here, again, the technique is completing the square. Since a is 1 and b is even, that's a nice one to do completing the square for. So I'm going to take this b value, divide it by 2, which is 3, and then square that for 9. So now this not only factors, it's a perfect squared trinomial. So what are 2 numbers that multiply to 9 and add to 6? That's 3 and 3. For this one here, I'm going to divide b by 2, so it's negative 1, and then squared is positive 1. And I'm going to add that to both sides, for both these numbers, adding 9 to both sides, adding to 1 to both sides. This is now a perfect square trinomial, so not only does it factors to 2 things that are the same thing. So what are 2 numbers that multiply to 1 and add to negative 2? It's minus 1 and minus 1. So this factors to y minus 1 squared. And then this is 3 plus 1 is 4. So now in this standard form, I can see that the center is negative 3, 1, and the radius is the square root of this, which is 2. All right, 2 more here. So 61. So find the values of y such that the distance between 4 and some random y value and negative 2 and 6 is 10. So what I'm picturing is like you go to the point negative 2, 6, and then at 4 you might go up and down or something like that, because there's going to be 2 places that'll be a distance of 10. Okay, so what I'm going to do is I'm going to set up a distance formula, but in this case I know the distance is 10, so I'm actually going to plug distance squared as 10. So my distance formula would be take the difference in the x's squared plus the difference in the y squared. So 4 minus a negative 2 is 4 plus 2 is 6 squared plus y minus 6 squared. So I get a little equation here, and that's equal to distance squared. And I know what that is. That's 10 squared, which is 100. 100 equals 36. And now this FOILed out is going to be y squared. Minus 6y minus 6y is minus 12y. And then minus 6 times minus 6 is plus 36. Make sure to FOIL this. Again, it's not just y squared minus 6 squared. You can't just distribute the exponent because of that minus sign. It's not all multiplied together. There's a different rule when there's a minus sign there. Okay, so let's bring the 100 over. Let's rearrange everything and to get it in quadratic form here. Let's see, so ax squared plus bx plus c, y squared minus 12y minus 28. And then are there 2 numbers that multiply to negative 28 and add to minus 12? That is minus 14 and positive 2. Again, if you forget how to do that, one thing we can do is go to our calculator again, and I'm going to put this minus 28, and I'm going to divide that by x, and then I'm going to go to my table here. I'm going to change what I'm counting by. Let's start at 0, and let's count by 1s. So now when I go to my table, let's see, I'm seeing everything that multiplies to a negative 28 now. So if you divide negative 28 by this, you get this. What that really saying is these numbers multiply to negative 28. So now I'm going to look for the combination that adds to a negative 12. So since this is negative, the bigger number is negative. So I'm going to go this way. And then there's the 2 numbers that multiply to negative 28 and add to a negative 12. Positive 2 minus 14. So that means the points 4, 14 and 4, negative 2 would be a distance of 10 from this point here. Okay, last one, 71. Okay, so I'm going to use my graphing calculator and then kind of graph this. So again, if you did this on Desmos, you can do that pretty quickly. That's going to be x squared plus y squared equals 36. So let's kind of change our window here. Okay, looking here, again, I have a circle that's centered at 0, 0 with a radius of 6. So from 0, 0, I'm going to go up, down, left, and right to create that circle. So that's all easy and fun to do. If you want to do it on your TI, well, it's a little more work because you got to put it in y equals form. With Desmos, you don't have to, but with your calculator, you do. So how do you put this in y equals form? Well, you can subtract the x squared. That'd be 36 minus x squared. And then square root both sides. Don't forget, if you square root both sides, the plus or minus. So what I can do is I can graph plus root 36 minus x squared. Oh, forgot that x squared there. And then minus root 36 minus x squared. So if I graph those separately here, y equals second square root 36 minus x squared. That is going to be the top semicircle. And then the bottom one is going to be minus square root 36 minus x squared. And that's going to be the bottom semicircle. Now it looks kind of ovally, so what I can do is I can hit zoom, and because my window, it's longer than it is tall, but it's negative 10 to 10, it's 20 units this way and this way. So if you want to square your window, you can do zoom 5, and that squares it. To create the circle. Now there's always some kind of weird things when you do squares of small numbers, so it might not look connected, but if you go to your table and you look at 6, both of these function connect at 6, 0, and if you go negative 6, it also gets, and if you notice, you can't go beyond that. There's errors there, so I'm seeing this nice circle here. So good viewing window, you can do negative 10 to 10 by 1, but really, once you see that, here you need to see negative 6 to 6, and then negative 6 to 6. So you can really write any answer here, but this x min, x max, x scale, y min, y max, y scale will get the job done. So remember, this is square root of 36 minus x squared and minus root 36 minus x squared would be these two graphed separately. So hopefully you had fun with this homework. I'll see you next time in class. Take care, everybody.